Hydrogen is in the sky, rising beneath the moonlight. No more carbon, it's electric flight. Wings of change, they cut the air. Hydrogen dreams everywhere, flying clean without a care. Feel the lift, feel the flow. Up we rise, where dreams go. High sky, hydrogen, let's go, let's fly. No carbon clouds, no smoke in the sky. Sky high, hydrogen, the future is clear. Clean air above, the world is here. Taxis soar like birds at dawn. Drones deliver hope reborn. Helicopters whisper songs. Every rotor, every flight paints the world in shades of bright. Feeling freedom with the light. Freedom with the light. Freedom with the light.
Wheels never touch the ground below. Blades hum a song the future knows. Carving lines through the open air. Dreams we chased, now we're there. Zero burn, clean we fly, rising fast.
The high sky. High sky, where the engines hum. High sky, where the future's won. No smoke, no chains, no need to try. We just go in the high sky. In the high sky. Hydrogen is in the sky, rising beneath the moonlight. No more carbon, it's electric flight. Wings of change, they cut the air. Hydrogen dreams everywhere, flying clean without a feel the lift, feel the flow. Up we rise, where dreams go. High sky, hydrogen, let's go, let's fly. No carbon clouds, no smoke in the sky. Sky high, hydrogen.
Good morning. Good morning, afternoon, and evening, everybody. Welcome. Welcome to the first High Sky Monthly of 2026. Also, Happy New Year. I hope you enjoyed that song and woke you up. I certainly did. Gotta love AI. So yeah, Happy New Year, everybody, and thanks so much for being with us. We have a really special guest today. First, we'll get into a couple announcements, and of course, I want to wish everybody a happy MLK Day. Excuse me, I'm still getting over the flu. I'm better, but remaining yuckiness. But yeah, I just want to take a moment to honor Dr. Martin Luther King Jr. and the legacy we reflect on today. Dr. King reminded us that progress requires courage, persistence, and a commitment to serve something bigger than ourselves. On MLK Day, we're reminded that building a better future isn't passive. It's something we choose through our actions. Thank you for spending part of today with us to keep moving that work forward. Next, I want to say congratulations to all of the High Sky Award winners from 2025. That's the video that you were just seeing. And let you all know that we are launching the High Sky Connect Hydrogen Safety course on February 3rd. You definitely want to attend this. I don't know what is going on with my voice. I've literally been fine for like 2 or 3 days. And then when I go live, it does this. Perhaps a drink. So definitely get involved in this course. This course is really going to set the tone for the safety things that we need to follow in hydrogen aviation. So that is a 5-week course. That's a 3-week course. It's 6 classes, 12 total hours. We have all kinds of discounts and ways that you can save money on that course. So the link, let me give you the link for that to learn more in the chat. And next up, I just want to let you all know that on Thursday, I will be presenting hydrogen aviation, what it will take to make zero carbon flight real at the Transformative Vertical Flight Public Service Working Group. And the meeting is January 22nd at noon Central. And then let me give you the link to register for that as well. That'll be informative. Just a topic that I'm very passionate about. And I'll kind of talk about on-site hydrogen production, mobile, trailers, and then scaling up a little bit to these modular refueling stations, and then finally to large passenger aircraft and airports. So then next up, 2026 Transformative Vertical Flight is coming up in San Jose. Let me give you the link for that. That's an in-person event. Oh, sorry, Mike. I just realized I'm accidentally putting those links to the private chat. Okay, let me give you those links again. Welcome from Ukraine, from McKinney, Texas. I'm just putting these links. So the first one is to the course. The second one is to Thursday's presentation that I think will be really important for this group to attend. The third one is for the in-person event. And then the fourth one finally is for Verticon, which some of us are going to. There is a hydrogen panel at the Transformative Vertical Flight. There is not at Verticon, but there are some hydrogen folks. So now I just want to invite anybody if they have any other announcements. Mike, if you want to come on, if you have any other announcements that I forgot or share a little bit more about TVF or Verticon, you're welcome to do so now.
All right, great. Thanks, Danielle, and hope your voice comes back. Yeah, so lots of exciting things going on. I've been busy helping the Vertical Flight Society with their Transformative Vertical Flight big meeting next week. We do have a session on hydrogen, and that's going to include Dr. Anita Samgupta, the CEO of Hydroplane, Gad Shannon, the CEO of Unmanned Aerospace, and I believe John Piasecki, the CEO of Piasecki Aircraft, all talking about their hydrogen VTOL aircraft developments and other CTOL variant CTOL technology developments. In addition, we have Willy Take from Germany, who's been a real reporter and observer on the developments in China and also in Europe. And so he'll be talking about some of the hydrogen conventional takeoff and landing and vertical takeoff and landing activities. I do want to mention also that VFS, AIAA, SAE, and the Royal Aeronautical Society are organizing their SAE, the International Powered Lift Conference, IPLC, at the SAE Aerotech in June in Florida, West Palm Beach. And we're looking to hopefully put some hydrogen discussions there as well. Thanks, Danielle. And I'll put some links in the chat.
Thanks so much, Mike. Awesome. Okay, now let's get into today's speaker. We are so excited about today. I've been waiting for almost a year to have Edge come and talk. So Erik Limpaecher is CEO of Edge, which develops expeditionary infrastructure for producing hydrogen from metal aluminum fuels. Edge's systems fuel air, ground, and maritime applications in the defense, construction, agriculture, and mining industries. Erik has 25 years of experience in military and energy R&D and entrepreneurship. He has co-founded 4 energy companies, a research group at MIT, and 1 new Department of Defense office. Goodness. He has served on the Defense Science Board and has won R&D 100 award on 3 occasions. Erik's teams have developed half a dozen UL and MIL certified power conversions, renewable energy, battery, and aluminum and hydrogen-fueled products for the commercial energy sector and U.S. Army and Navy. Thank goodness I'm done talking. Without further ado, please welcome Erik Limpaecher to the stage. Erik, the stage is all yours.
Thank you, Danielle, and I'm glad I can give your voice a little break. Let me share my screen. Are you able to see that?
Yep, looks perfect.
Excellent. Well, as Danielle said, my name is Erik Limpaecher. I've been working in remote energy for over 2 decades, and in specifically expeditionary hydrogen generation for the last 8 years or so. And Edge is commercializing a technology that we spun out from MIT Lincoln Laboratory to enable expeditionary infrastructure through the production of hydrogen using aluminum metal fuels. And today is actually a very pretty interesting day, unique day in hydrogen aviation history. On this day, 110 years ago, was the first air raid on Britain from hydrogen-lofted Zeppelins. So quite a coincidence. A little bit different than MLK theme, but given that we're focused on hydrogen aviation here, thought I'd to mention that. And the use of hydrogen for lift gas has 160 years of history, dating back to the Civil War, where hydrogen gas generators were used to loft balloons for surveillance. In the First World War, over almost 6,000 hydrogen fuel missions were carried out with these 2-person aerostats for artillery spotting and surveillance. And they transported the gas from French factories in these compressed gas cylinders. And then in the Second World War, the M1 hydrogen generator was used to loft these barrage balloons. You can see these over the beaches of Normandy. They're also lofted over Buckingham Palace in London during the air raids, protect against in the aircraft. And they use caustic soda to produce hydrogen using these mobile hydrogen generators. And today, DLA supplies hydrogen to the DoD. It comprises 5% of all DLA hazmat shipments. And the Army is in the process of establishing high altitude balloon platoons in both the Pacific and in Europe. But lift gas is not the only application for hydrogen. The Navy's developed combustion-like gas guns that demonstrated 30% higher muzzle energy by combusting hydrogen and oxygen for both 45, 105, and 155 millimeter guns. hydrogen has been demonstrated to provide significantly reduced thermal signature and acoustic signature compared to combustion engine systems. Through some analysis, we've also shown that hydrogen can provide significantly increased range compared to diesel-based combustion engine vehicles because hydrogen systems tend to run at much higher efficiency than at lower operating load levels compared to combustion engine vehicles. Furthermore, hydrogen has been shown to be very safe. On the left, you see a video of a Toyota Mirai tank being struck by 50 cal, and you can see that because of the exhaust of the hydrogen actually prevents any ignition. And on the right-hand side, you can see some tests done by University of Miami showing the hydrogen, when handled properly, is actually safer than gasoline-based for vehicles. I'll let that video play for a second. As we look to other applications, as you all know, hydrogen has significantly higher energy capacity compared to batteries. So today, we could see a 3 to 5 or further, 3 to 8x improvement in the flight endurance of UAVs. And I think it's interesting to compare that to the amount of improvements in battery energy density we've seen over the last 50 years. Right? That batteries have improved by 7x over 50 years, and today, by switching to hydrogen, we could dramatically improve the energy density compared to batteries. Which is why there are so many companies developing hydrogen fueled drones by removing the batteries and using that same battery electric powertrain to fuel hydrogen electric systems, as well as a pretty robust ecosystem in providing battery to hydrogen conversion kits for primarily Group 2 and Group 3 UAVs. I've actually seen IAI and SkySyn develop or converting combustion engine UAVs, Group 2, Group 3 UAVs, hydrogen due to improved maintenance and reduce acoustic signature. So that's a quick run through of some defense applications. We've seen a lot of interest from the Special Operations Command and the Army in contested logistics. And the basis for that is that petroleum has historically been a challenge for military operations and is frequently the first thing targeted by the adversary. Good news is that there are many other sources of energy in places where the U.S. military might want to operate, and many of those can be used for producing hydrogen. Right? You can use coal, you can use natural gas, you can use electricity, and you can now also use aluminum. So potential operational energy, potential solution to contested logistics is to use local available fossil or electric power sources to produce hydrogen regionally and then transport it, or operating at the tactical edge, you can now take aluminum, mix it with water to produce hydrogen on the spot. And that technology is what Edge has been focused on commercializing. When you look at the map, there's some pretty interesting use cases in terms of using aluminum as a sovereign fuel, the ability to take locally sourced either primary or secondary aluminum and turn into hydrogen or as a fuel source. And furthermore, given that aluminum is a globally traded commodity, there are large stockpiles in certain areas. This one site in Vietnam, which has aluminum stockpile 2.5 miles wide by a mile deep and taller than a person, has as much energy using our technology as the entire Navy Red Hill fuel depot in the Pacific. So, significantly large quantities of energy being stored in the form of aluminum around the world, now being accessible using our technology. So when you compare aluminum-based hydrogen to petroleum, there's some significant benefits. We see about half the volume and about 10% more weight. You can use any type of water along with some additives to produce both water and because it's a chemical reaction, we can do the reaction in a pressure vessel, and the pressure vessel produces pressure, and that system can then pressurize reverse osmosis system to do water purification. So, quick run through as to why the Army and SOCOM and Marines are interested in aluminum and hydrogen specifically as a contested logistics solution, not as a way to replace diesel, but as a way to augment or increase the number of options that they have. So now I'm going to get into the moonshine hydrogen technology we've been developing to meet those needs. So this video shows what's happening inside of our reactor. The aluminum has its oxide layer disrupted. That's why it doesn't look so shiny. And when it's exposed to water, aluminum oxidizes inside the water, rips the oxygen molecules off the H2O to produce aluminum hydroxide. That's the gray material there, and then allows hydrogen to go free. So all those bubbles there are hydrogen being produced with no electricity needed and any type of water. I used to have there was a Marine Corps colonel who liked to sabotage my demos by pouring hot coffee over the aluminum and start reacting and producing hydrogen using the water from the coffee. We've done significant work on this technology at MIT Lincoln Laboratory. We've got exclusive license to over 10 patents from MIT. We did systems like the hydrogen tactical refueling point, which enabled a handful of Marines to produce hydrogen for fueling UAVs and powering a combat operations center, producing power. We've done balloon launch projects and a number of other projects while at MIT from 2018 to 2024 when we spun out the company. So Edge is now commercializing this technology using one fuel for many applications. The simplest thing you can do is to fill a balloon, feel it tight or high altitude balloon, carry a communication relay up in the air and provide over the horizon comms and sensing. You can run a fuel cell to produce electrical power. You can use the pressure that's produced by the chemical reaction to pressurize a water filter for water purification. And you can also self-pressurize up to 5,000 psi to refuel unmanned systems. So all the way from ambient pressure up to 5,000 psi are enabled by two reactors. This is our low pressure reactor, and we're also developing a higher pressure reactor for expeditionary applications. We group our work into three domains: air domain, which is aerostats and drones; ground domain, which is power generation and water purification; and maritime domain, where we basically take the ground power system, put it on a watercraft, and effectively build an ocean sipping watercraft, where the watercraft carries the aluminum and then can ingest seawater for the reaction. So the technology is as simple as pouring raw aluminum into the reactor, and then the reactor does all the mixing with water and thermal regulation in order to make the reaction work. So this is an early demo, or early test we did, producing several hundred grams of hydrogen in about 15 minutes. We've done as fast as a kilogram in 5 minutes. That was a very sporty reaction. This one shows a much more mobile system using environmental water. So one of the earliest tests we did was we brought this to Michigan, to Lake Huron. We participated in the Navy's Silent Swarm exercise. We took water from Lake Huron along with aluminum, mixed it in the reactor in order to loft an aerostat. That aerostat then was able to integrate with a number of different communication payloads, both our custom developed Growler radio, which operates below the noise floor, using a LoRa-based network. We've also integrated with GoTenna and Domo Tactical and Chatterbox. All those systems were able to communicate over the horizon because of the additional altitude that we brought them to, which enabled some pretty unique capabilities. Flying just at 500 feet, you're able to demonstrate 23 miles line of sight communications, where typically if you have a radio at eye level, you can only get about 3 miles, best case. We also demonstrated multi-hop mesh communications by lofting 2 aerostats and having multiple operators communicating over the entire AO of the exercise. This technology was assessed at TRL 7 by the Navy. Looking forward, so based on that test, we were selected into the NATO DIANA program. And since then, we've been engaging primarily in Eastern Europe with the idea of building what we call microfactories. We can take locally sourced aluminum, chip them into usable pellets that our reactors can use, basically glorified gumball dispensers. And then those reactors can be used to, or that aluminum can be used to feed reactors that can loft aerostats for enabling wide area communications and sensing for communications, as well as fueling of hydrogen ISR drones. This right here, for example, is the Zephyr Z1. for enabling cargo drones and significant range on those as well. So, one technology, one fuel, common set of reactors, enabling a range of applications in some interesting places of the world. So, looking ahead, EDGE has several Special Operations Command contracts to develop both remote power generation, water purification, and drone pressurized fueling. We're about to kick off an Army project as well. We're engaging with 2 program offices, both in the Army and the Special Operations Command for power generation. We're recognized as being the top 3% in technology solutions for Army contested logistics and the top 1% of technology solutions for NATO DIANA. We are currently standing up a air launch operations team, operationalize our capabilities globally. We're engaging with a Pacific Island nation, country in Africa, flying to a remote island in the Southern Atlantic, as well as Eastern Europe. These include both aerostats, high-speed balloons, tactical power, and drone fueling capabilities. Thanks to some of our investors, we're expanding into the mining, agriculture, and construction space. So anybody who has needs for either sensing or communications or remote power. And we're seeking partners, both strategic investors and folks who may be on this call, hydrogen consumers at the edge. So if you're finding that hydrogen supply, hydrogen pressurization in the areas where you're operating are challenging, we definitely be interested in speaking with you. This is definitely not a one-person show. The leadership team is incredibly talented. Mark has been developing autonomous systems for the past 25 years. Doing his work at MIT Lincoln Laboratory. He's also an instructor in robotics at MIT. He's developed unmanned systems operating under sea and land and air and space. He even developed a self-guided bullet. He's been the person who addressed all the challenges with aluminum as a fuel. And many other people working with aluminum require either powdered aluminum, which is explosive and inhalation hazard, or they require precious metals that are consumed, or require complex or heavy equipment for the aluminum production, or they require the aluminum to be water reactive and hazmat. Mark is the one who solved all those challenges, enabling moonshine hydrogen to be a commercially viable solution. Alex has been is an Army veteran. He advised 2 presidents in the White House, and he's been doing disaster response deployments throughout the world over the last 15 years. He's also the team lead for the Roddenberry Foundation Disaster Response Team, which is the philanthropic arm of the Star Trek franchise. And that's how he and I actually met. He's been managing government contracts for many years. So these are my co-founders. The team is small, but very nimble and fast moving, and I look forward to your questions.
Awesome. So in the chat we have a few, but I want to start by well, first, thanks for sharing that, because I've been curious about this technology. Many years ago, I was talking to some Army guys. You might even work with them. They mentioned something about these pellets. I've heard about it. I've heard about this aluminum kind of dust thing, and I didn't know if it was really real. So that's the first time I've seen a video like that. Thanks for sharing. I've always wondered if it was actually possible. My question is, so as somebody with a background in manufacturing and aerospace, I've seen many aviation graveyards with loads and loads of aluminum that's just sitting there. Would it be possible to recycle that and make these out of that? Because I always just thought this metal is valuable and there's so much of it out here. I don't know what you can do with it's been coated with chromium and things like that. Is it possible to take some of that? Where do you get the aluminum is it possible to use that graveyard metal?
I don't know specifically about that type of aluminum, but we have taken a wide range of aluminum alloys and used it for the reaction. In fact, at one point, I took a soda can from the Pentagon cafeteria and turned it into hydrogen on a general's desk in 15 minutes. using equipment at Project
Interesting.
Pentagon Security into grocery bags. So you can use a wide range of aluminum. And it's just a matter of chipping into little pellets that our reactor can use. Depending on the alloy, you can see different efficiency levels, but by and large, aluminum can be used pretty broadly. And
What
that's
is
one of
the
the things that's
main
also
one that?
interesting. It's also one of the things that's interesting. Are some of the European partners, right? In Europe, they have a very robust recycling system. So they effectively have sources of aluminum at every single grocery store. So in terms of enabling a sovereign fuel or a fuel that you could source locally, aluminum would be ideal.
Yeah, interesting. What's the most ideal aluminum or alloy? Do you have the number? I forget what it's called, but you know how they have a number that coordinates with it?
Yeah, the technology works with a wide range of alloys.
Interesting. That could be an interesting path. Okay, so the next question I see, and um I'll probably have more as well, is Sarah. Sarah, would you like to unmute and come on and ask Erik your question? Also, everybody, thank you so much for being with us on Martin Luther King Day. Erik did mention, should we postpone it? We always do this on the third Monday, and usually we get a lot of folks on MLK Day, but maybe I should have listened to you, Erik, because we didn't have a huge turnout today. I suspect, but I suspect the replays will be there. Sarah,
I'm
please
here.
come to the stage. There you are.
Yeah, obviously, any new innovation for me and for folks like me is kind of exciting, but at the same time,
Sarah, do you want to introduce yourself and who you're with so Erik kind of has an idea?
yes. Erik, I'm a commercialization strategist. I support SBIR grant recipients with technical and business assistance services, and I've been involved in a couple of projects with MDA. But anyway, so from that perspective, obviously there's a whole lot of innovation mobilization happening in the defense tech space, and obviously there's a lot of funding going in that direction. I'm kind of wondering if, as civilians, right, should we be concerned? And do you foresee the funding tapering down once I guess new assets are acquired and obviously planes are replaced and technologies and things are better for your purposes are done. From my perspective, obviously the funding that has shifted toward defense away from healthcare or energy is a little bit disconcerting. So I just wanted to kind of hear from you what your thoughts are.
Yeah, so we've seen a real positive shift in the last just couple of years in terms of all the services, in terms of their interest in hydrogen as a potential fuel solution. Part of that comes from concerns about dependence on Chinese lithium-ion batteries. Or people see hydrogen as a potential mitigant for for batteries. Contest logistics. As people are looking towards the Pacific, they're scratching their heads as to how they're going to be able to supply petroleum over such wide areas. We're not saying that hydrogen and aluminum are going to be a replacement, but it does provide augmentation for petroleum-based solutions. The need for energy is continuing to rise. In fact, let me pull up this one slide here. So this shows the fuel consumption, gallons per soldier per day over the last 100 years. And the last data point here is in 2000. I would imagine if you plotted numbers for the future infantry regiment that's flying lots of drones, this number is going to be even higher. And the fact that more and more of this fuel consumption is for electrification, and combustion engines are not particularly efficient at producing electricity, while hydrogen is highly efficient at producing electricity. We see this as a problem that is not going away. And so, there's language in the NDA from both the Army and Marine Corps about hydrogen-based solutions. Program manager for Molecular Power and the Marine Corps Power Team are both interested in hydrogen-based solutions, and that they've already adopted battery-based microgrids. So, we think that there's for both technical and logistics and operational reasons, there are many forcing functions that are causing the military to look to hydrogen, help them solve their battery and fuel challenges.
Thanks so
May I answer your
much.
question?
Yeah, thanks so much for sharing. That slide was very interesting. Where did you guys make that, or was that from a paper? Where did that come from? That was, I'd love to dive into that a little bit more.
Yeah, the reference is here on the bottom.
Could you put that link in the chat?
Sure.
Okay, next up we have Hermit Badness. Hermit, I apologize if I'm not saying your name right. Very good question. Would you like to come on and ask your question?
Eric, thank you very much. Really appreciate this presentation. I'm with the San Diego Airport, and we're looking at several options to power for alternative power. One is emergency power for when, again, emergency power at times when we anticipate there will be some sort of energy blackout. So we use diesel generators. That's what we use, and I believe that's the standard. And I don't know how this could potentially replace diesel generators for emergency power to power our terminals. That's the first thing. The second is we're also using a significant amount of solar to power our terminals as well. So on a per square footage basis, we know how much solar energy we can generate via solar, but how would we, replace solar with aluminum fueled hydrogen? And how much energy would we generate, maybe not on a per square footage basis, but on a per pound of aluminum? And then third, we were also looking at fleets, powering fleets and converting our current, ICE fleet into some sort of maybe fuel cells, but how would we do that affordably using aluminum fueled hydrogen generated at the source? Right. So those are my three questions.
Great. Yeah. So let me just share this slide again. So in terms of comparison against diesel, aluminum produces twice as much energy per given volume, and about 10% less per given weight. So, and the other thing that I think is interesting to note is that it can be stored outside in the elements without worrying about environmental contamination, right? So people always worry about leaking diesel tanks. They worry about keeping their diesel fuel fresh and having to refresh it every year. Those problems don't exist with aluminum as a feedstock. Also, on the construction industry, they're interested in aluminum as an energy source because of reduced noise emissions and reduced particulate emissions. Right? There's almost no noise emissions because the chemical reactor and the hydrogen fuel cell are nearly quiet, and there are no particulate emissions either. So, from both an EPA standpoint and a backup energy stockpiling standpoint, aluminum provides significant benefits compared to petroleum. And as long as you're looking, right, it's challenging for us for a new energy technology to compete against electricity and diesel that have had over 100 years behind down the cost curve. But if you're using it as a backup power source, it can provide significant benefits at a comparable or competitive price compared to petroleum. So you'd asked about backup power. What were the other two questions? You talked about fleets. So we are working on the robotics refueler, the system that self-pressurizes the hydrogen to 5,000 psi or higher. Our initial target is for drones, but we have been talking to various manufacturers of construction equipment who are looking to reduce the noise emissions and pollution emissions of their vehicles. I would imagine that the same would be true for aviation, ground fleets. I don't know what the status is in terms of those manufacturers providing battery electric or hydrogen electric variants. But those are different options. I think those are two of your questions. What is the third one that I missed?
Using aluminum fueled hydrogen as a replacement for solar power our aircraft, our building terminals. So is it a viable replacement for our existing solar?
Yes, in the sense that, right, you can produce aluminum-based energy at any time, right? You don't need to depend on the sun shining or clouds being, the sky being clear. Once you make the solar investment, the electricity is effectively free, so it's hard to beat that. But if you're looking to expand your capacity or looking for energy that's available 24/7, it's definitely provides benefits compared to solar in that regard.
Great. Thank you very much.
Thanks for that question. Let's see. Next up, we have Matt Fairley. I hope I'm saying that right, Matt. Do you want to come on and ask your question? And while we're waiting for Matt, Eric, could you share your screen again? I'm just going to nerd out for a minute because I really want to understand how this works. I think it was, if you share your screen and go back to where you just were, I think it was like 2 slides after this. Okay, right here. Could you explain so in the bag, what's in the bag?
So this is actually a demonstration of what we call our Generation 1 fuel, where we disrupt the oxide layer. Like the aluminum isn't shiny like it typically is. That aluminum oxide, that aluminum rust is what prevents it, typically from reacting with water, right? So you have a aluminum soda can or aluminum spoon, right? They don't react with water because of that shiny silver aluminum oxide. With our Generation 1 fuel, we strip away or disrupt that oxide layer, and then that makes the aluminum water reactive. Since then, we've actually, and this video is showing that Gen 1 fuel because it produces the hydrogen immediately, and you can visually see it. Since then, we've upgraded improved our technology. Our Generation 2 fuel does not require that pre-processing step. So now you can just pour raw aluminum into a reactor like we showed here, and along with a small amount of additive, it mixes it with water and turns it into hydrogen. But it works on that same principle where you disrupt that oxide layer, so that the aluminum, when you pour it into the water, aluminum likes oxidizing. It'll oxidize with the H2O. It'll rip the O off and allow the H2O free.
So interesting. This might be a silly question, but I'm always curious in ways that we could store hydrogen or make hydrogen in a way that maybe doesn't need to be liquid or cryogenic, subcooled. Would it be possible to generate this hydrogen on board of an aircraft, or would that require like too much, additional, then you need your reactor and water, et cetera. Have you guys looked into that?
So the challenge is the water, right? The challenge is the water.
Yeah.
Water is heavy. That's why we've been, when we illustrate our air, ground, and maritime, the air system, the reactors on the ground, it basically acts as a mobile gas station. The ground systems, they produce hydrogen and it's consumed on demand, right? So as soon as you produce it, the fuel cell consumes it and it produces electricity. And then but the maritime is what you were envisioning, where you have the reactor on board the platform. So you have the reactor on board the water. It carries aluminum. It can also then ingest water from the environment and produce hydrogen on demand.
And then you guys make the pellets, excuse me, correct?
Yeah.
That's your entire...
That's a fairly straightforward, mechanical processing step.
Is it, what's the
so
energy requirement?
Total all-in energy to take the aluminum, raw aluminum, let's say, some form factor, like, I don't know, some sheet, process it, put it through our reactor, the water pumps operate, those consume a little bit of electrical power, and then produce electricity through the fuel cell. All in, we consume about 1.8% of the energy that comes out. So aluminum has twice the energy density of diesel, 8 kilowatt hours per kilogram. The maximum, 8.6 kilowatt hours per kilogram. Massive amount of energy. That has come from some sucker putting the energy in, right? You start with bauxite. The smelting process for aluminum is very electricity intensive, right? So all the energy is embedded in the aluminum. We're basically undoing, we're recapturing that energy that somebody else at the smelter put in, and we're replace it. And because we're just doing mechanical and chemical steps, it's highly energy efficient. Again, only 1.8% of the energy that comes out you need to put in for release.
Oh, that's so interesting. I could definitely ask you questions all day. I think I will need to get you on my podcast next. Matt, I don't know if Matt is still here. Matt, if you are up to ask a question. Let me just see if he's still here.
Oh, thank you, Danielle.
Go ahead. Yeah.
It's Matthew Faraday here. So two questions. One, there's a residual aluminum oxide that's left over. Does it have any economic value? Or is it contaminated to a degree that it is simply disposed of?
Yeah, so we're producing aluminum hydroxide, which is actually the main ingredient in incandescent medicine. So in theory, it could be a medical product. We're not necessarily producing at the purity you would want to have it be put into pills. But it is, it is benign. We've run EPA T-clips on it, and EPA has found that there's nothing hazardous or toxic in it. Because it is effectively going back to producing bauxite, it's effectively dirt. So at some locations where we've tested, we've gotten permission to dispose it on the ground because it effectively turns into dirt, like 24 hours later. It could be used in some cases as either a fire retardant, like in gypsum boards, you could use aluminum hydroxide instead. Or you could, one of our customers' interests, because it is slightly basic, it could be used for deacidification of materials. So people are looking to use it to deacidify coral reefs and those sorts of locations. So there are potentially some secondary economic value streams for it, but typically we treat it just as a waste and dispose of it in the municipal waste stream.
And my second question is, what is the advantage of the aluminum water hydrogen fuel cell versus the aluminum air battery? What advantages do you see?
So the aluminum air battery, right, it produces electricity natively, and that's the only thing it does. Right? With our technology, by producing hydrogen first, you now have options as to what you do with that hydrogen. Right? You could use it to produce electricity. You could, pressurize it to file a drone. You could use the pressure to do reverse osmosis. Right? Because we're producing hydrogen, not electricity, it provides a different set of options in terms of how to use it.
Very good. Thank you.
Great question. Let's see. Next up, we've got Philip. I think Philip might have left, but he did ask. By the way, Philip will be one of our upcoming speakers. Philip Ruiz. What is the purity of the hydrogen produced this way?
We actually just got our purity test results back from Airgas. So not Airgas, but from Atlantic Analytical, and they've found that our hydrogen is fuel cell grade.
Nice. Very cool. And that doesn't matter what type of aluminum or alloy you're using, or does it?
The only thing that could trip us up is if there's like cutting grease on the aluminum, right? The grease may have sulfur in it, and the sulfur obviously is no bueno. So as long as you are careful not to have oil in your water or in your or on your aluminum, then you're okay. But even the amount of sulfur that will be produced could be relatively easily scrubbed out with a sulfur trap.
Okay, nice. Let's see. Next up, Sergey Arashlanov. Apologies if I'm butchering your name. Please come on and ask your question. Also a great question. Sergey, are you here? Looks like you're here.
Oh, sorry.
No worries.
I have a simple question, Eric. What is the cost of 1 kilogram of hydrogen or according to your estimates? What's the cost?
The cost of the hydrogen depends completely on the cost of the aluminum. We produce 1 kilogram of hydrogen for every 10 kilograms of aluminum. And so the price can range anywhere from $10 per kilogram of hydrogen up to what was it? From like, $100 per kilogram of hydrogen. It completely depends on the cost of the aluminum. We have found that we are highly competitive with compressed gas cylinders that are typically shipped for with hydrogen, looking to be about half the price of shipped gas cylinders in many locations. But again, it depends on the cost of the aluminum that we use as their feedstocks and the transport considerations of that.
Okay, thank you.
And I think that addresses Albert's question as well. He asked how much aluminum per gram of hydrogen. The ratio is 10 to 1. So for every 10 grams of aluminum, you get 1 gram of hydrogen.
Perfect. And that's kind of where my mind was going when I was asking you if you had looked at the graveyards. Have you all recycled aluminum? I'm just wondering if there's an opportunity, if it would make it a little bit more sustainable, affordable, looking at recycling used aluminum, or like what's your source, if you can say, like what works best? I know you said all kinds, but what have you done so far? Like where have you gotten that aluminum?
We've bought every type of aluminum we can find on Amazon, Alibaba, local suppliers, you name it. We've tested it, very extensively. There are, so we've done extensive testing right now, just due to, trying to reduce the amount of variables in our reaction and our product. We're using just a handful of aluminums that we've been, that we pre-tested, we know are very highly efficient and cost effective. But down the line, part of our plans are to build what we call a microfactory, which can take any type of aluminum, process it mechanically, shred it, ship it, compact it, in order to have it be used as a feedstock. But that's slightly further down the line.
Did you say you were TRL 6?
The reactor and the fuel are TRL 7 as of 6 months ago with the Navy, and we'll be pretty soon deploying it to the Pacific, which will be TRL 9. And then the drone fueling and power generation capabilities are in the TRL 6 range.
Nice. I'm just wondering what to make those pellets, how do you want, you mentioned cutting and shredding, like what is the best way to have that aluminum? Like this is where my mind is at. So you already talked about the graveyard, but also in Wichita, there's a junkyard. It's just kind of like a for cars, what is it called? I'm totally spaced on what do you call when you go buy parts out of an old car?
Scrapyard.
I guess a junkyard. But they have car stuff, but they have a lot, because it's in Wichita, they have a lot of manufacturing and aerospace there. They have where you can just buy like the actual skins of the aircraft, like huge sheets. I don't remember what they are, but it's at least probably like 8x4 sheets of aluminum. And they had to scrap them because, say, it had damaged, maybe a little bit of rain, a little bit of corrosion. And we used to buy those, cheap. We used to buy them for a few dollars to do, experimental building aircraft projects at the college. And I'm wondering if you could take one of those sheets of aluminum, so like a skin, and use it. And what would you need to do to it? What's the size of the aluminum? Like, what form is the aluminum when you put it into the pellet maker? That was a lot, but
Yeah, so it typically depends on the form factor of the raw feedstock. It kind of determines what sort of processing equipment you would use, right? If you have wire, you can just use a chipper. If you have soda cans, you would want to have a shredder and then a compactor. Same thing with foil. With sheets, you'd probably want to nibble or chip them as well. We basically need them to be, our instead of using pumps like with diesel, we are using augers and gumball dispensers effectively to be
okay,
able
you
to.
did say that. Okay, gotcha.
So you want it to be
Interesting.
small, relatively small pellets the size of a marble or a pea.
Okay, gotcha. Albert,
Danielle,
yeah,
yeah,
go ahead.
may I get back to my question? It had two
Yes.
parts.
Yep.
One is how many grams of aluminum do you need to produce a gram of hydrogen? And also, what is the weight of the residue? Can you give me two numbers?
So it's 10 to 1, so 10 grams of aluminum for 1 gram of hydrogen. The residue, it's heavier because you're taking an aluminum and you're adding an oxygen and a hydrogen to it. I don't know offhand what that weight is, but it is slightly heavier than the aluminum because you're adding in, it's grabbing the OH from the water.
Okay. If you allow me,
Yep.
Eric, from one alum to the other, I just look at how many moles of aluminum do you need to get 1 gram of hydrogen?
How many moles?
Yeah.
I'd have to look up the chemical.
All right. Let me just say 2 moles because you need to produce Al2O3, right?
Yep.
So 2 moles. Now, 2 moles, a mole is 27 grams. 2 is 54. You get 3 moles of hydrogen from that. So if you divide by 3, you get 18, not 10.
Okay.
So you may want to check your numbers. The other thing is, if you add the water, my God, it's a huge amount. It's like 100 grams of residue produced at the end. That kind of tells me that hydrogen will work in very specific areas, and the military is a good place for. Certainly not on an aircraft, as someone was suggesting. You get a simple calculation like that could eliminate some application and help focus on what application one should go to. And unless this is done very quickly, sooner or later, there is a backlash. And I've been in business long enough to see many backlashes because I participated in the hydrogen economy in the 80s, in the very late 70s, actually. Okay. And then been a renewal since then. And now this is the third one in my history, so to speak. Okay. Anyways, she asked you for the numbers. You gave her some. I'm giving alternate numbers.
Yeah.
And I just did it as we were talking. Use can have a much better solid foundations, but whatever that foundation ought to accommodate my as well, then we'd be all happy, so to speak.
So your point is very well taken. We are explicitly not a hydrogen economy plant. My first company, we built power converters for wind and solar. And I learned the hard way that a new energy company, the last thing it should do is compete against diesel and electricity on price. So places where you have a power grid, places where you have diesel, petroleum logistics are nearly impossible to compete against with other alternate energy sources. Anyway, fortunately, it's taken now in the last 20 years, solar has come down in price enough that it can compete. But for that reason, we're focused on remote applications, places where electricity and petroleum don't have those advantages of infrastructure and logistics, right? So military, construction, mining, agriculture, remote oil and gas locations. Those all lack the infrastructure and lack the logistics to provide electricity and to provide mobility in a reliable and cost-effective way.
May I add one more filter? And one more
What's
filter?
that?
I'd like to add one more filter to your list. And
Yeah,
you
sure.
have free water. You got lots of water available.
Yes.
That
Yes.
really helps your case a lot, in addition to what you said.
Yeah. And not just that, but if, since we can use all, we don't need potable water. We don't need purified water, right? We don't need deionized water. We've run with seawater. You can use pretty much any type of water.
Yeah, for example, right?
Right. If we're in the middle of the desert, probably not a great application. But maritime, it's places where you have access to water that doesn't need to be clean. Our technology can work. In terms of the numbers, the ratio, the aluminum to, I had to go back and check the stoichiometry, but double check, your quick analysis. But aluminum to hydrogen, definitely 10-to-1, depending on efficiency, maybe as good as 9-to-1. It might be as bad as 11-to-1, but it's definitely that 9 to 11 range. Typically, when it comes to mass, because the byproduct can be disposed of locally or even in situ, people don't typically ask what the weight is of the byproduct. I should I should know that number. In terms of water consumption, the amount of water that's used in the reaction is minimal. The main driver in terms of water consumption is for cooling, right? So with this technology, you have 8.6 kilowatt hours per kilogram of energy in the aluminum. Half of that comes off as hydrogen, half it comes off as heat. You need a fair amount of water for cooling. That water can be reused, right? So once it cools back down, you can reuse it. And it also provides some benefits in terms of thermal signature, because unlike diesel engines, where it's exhaust their heat into the air, we exhaust our heat into water, so it makes it more manageable in terms of managing that thermal signature. Yeah, the water, not consumption, but water use and reuse, that is typically one of the main considerations in terms of where our technology is viable.
I also heard a question about recycling the alumina or the aluminum hydroxide. And the energetic of that are so hard. So I think find a use for it, okay, but to get back your hydrogen, forget it.
So, right, we're basically proposing to do that. You need a smelting plant, right? You effectively end up with bauxite. You need to effectively go through a smelting process in order to be able to turn that aluminum hydroxide back into alumina. There's one European team that was working on that, so kind of full cycle. I think there's another company called Found Energy that's working on that full cycle. I think the European team found that there were some impurities in the hydroxide that made it more challenging for traditional smelting plants to process it. Given that we are operating in remote locations, which are inherently energy poor,
right,
we're not proposing that as a method, right?
Yeah.
It's a single use, effectively like a primary battery. Use it once, you get a whole lot of energy, but then it's consumed.
Sounds good. Thank you. Good discussion.
Very good question. Thank you.
Yes, thank you for that. For the nerds, I think most of us are pretty big nerds. I'm rusty on stoichiometry. I would love to see though your stoichiometry, Erik, and then Albert's, so I could compare. I was trying to follow that conversation, but it was difficult. I'm a seer. I learn by seeing. So I would love to see those equations kind of side by side and see what you all were actually saying. Yeah, so that would be cool. So if you both feel like jotting those down and just sending me a picture of something we could share it, that I do think that was a really good discussion. I'd love to kind of see that written out. I have another question, kind of a pivot, but some of us have been putting together an advocacy group to go to NASA and say you all should be putting money towards hydrogen aviation. And why do you think that DoD seems to really get the Chinese battery problem, and NASA's very excited about drones and advanced air mobility and eVTOLs and et cetera. But with hydrogen aviation, I don't know, there hasn't been a lot really happening. Why do you think, I guess I'll ask two questions. Why do you think that is, with respect to NASA? And what would you advise us who are in talks with NASA to, show them, like, we've seen high tech and some of these, I forget some of the other ones that we talked about that you've won, where DoD gets that there is a need, maybe not from a sustainability point of view, but from, an austere environment, generating your own energy, especially to power a drone, or like you showed the soldiers' energy usage. How would we have that conversation with NASA to try to get them more engaged? So two questions. What are your thoughts?
So NASA is challenging. I've not worked much with NASA. We actually did look at using this technology of basically using spent rocket bodies on the moon, turning that into energy. NASA, not surprisingly, would prefer to use its water for drinking rather than reacting. So that was a fun project with JPL that did not make sense to pursue any further. In terms of hydrogen aviation, I think the challenge is cost. Unless you can produce hydrogen or your energy feedstock at a cost competitive point, while also providing the safety that the FAA requires, while also addressing logistics, while also addressing the aircraft design considerations and range. And those are all, it's hard to beat petroleum in those regards. That's why we've been focusing on drones, because there really is no alternate to batteries at the group 1, 2, and small group 3 scale, except hydrogen. And the benefits there are dramatic in terms of signature, logistics, supply chain, range, you name it. And we've been told that with many of those the drone manufacturers, they're seeing that hydrogen supply is one of their main barriers to broader adoption. So that's what interests a lot of our investors in that opportunity. Yeah, NASA, I can't really speak to. I've only really worked with them on a couple of occasions. But on the drone side and on the defense side, because of the other considerations like logistics and the hazards of transporting petroleum in those sorts of environments, there has been interest.
Okay, thank you for that answer. Go ahead, Albert.
I'll give you a very short answer. NASA's budget is about 25 billion. DOE is 200 billion, roughly. So it's almost 10 times. That is a big difference. That's why you will get more attention from DOE than NASA.
Well,
simple-minded way.
And the defense budget, I think the president's office request was an increase of 50% to 1.5 trillion. So there's a lot of money going into. One interesting thing to note, so the NATO DIANA program, which I think selected something like 30 companies the first year and about 70 companies the second year that we were in that cohort, and then now they're up to maybe double again that. Every single cohort has had at least 2 hydrogen-based companies. And so the NATO militaries, not just the U.S. military, but the NATO militaries are seeing hydrogen as a potential solution to both the logistics challenges and the operational capabilities. One of the most interesting companies to come out of the NATO DIANA program is a company called Kelluu, K-E-L-L-U-U, which is flying hydrogen-fueled, hydrogen-lofted airships for surveillance and data collection, and operating in some very challenging cold environments, including with fuel cells.
How did you spell that again?
K-E-L-L-U-U.
U-U.
So and we're looking forward to partnering with a lot of the drone companies that are on that map, including Roberto's company. He's on this call.
Yeah, Roberto has a question, actually. He's next. I was about to call on him. Roberto, please come on.
Yeah. So it's not just US DoD, also NATO and European militaries are looking to hydrogen as a solution, and I think it's up to us to find the right first kind of niche application. One other thing I'll jump in. I was presenting all these contested logistics solutions to the Navy, and the head of Navy operational energy turned to me. He's like, Erik, logistics wins wars. Petroleum is energy is the pacing function in the Pacific, and petroleum is a pacing commodity. But when it comes to actually unlocking significant dollars, you need a bang stick, right? You need something that goes boom. You need something that's kinetic, or something that flies further in order to be that initial point of adoption. And that's why we've been focusing on drones, because there is so much interest in drones. I think watercraft, USVs are probably the next big thing. It's good to see that Sergei Markov from Sea Cheetah is involved in this group. We've been looking for our bank stick, and then we can supply the fuel for them.
Yeah. That's an interesting point. That's kind of what my talk will be about on Thursday, of just the value in starting with the UAV space and how important it is. If we can get NASA to sort of understand that, that'll be huge. Roberto, I would love to hear from you. I'm not sure that we've met.
Just through email, Danielle, but it's good to see you here.
Tell us a little about your company, please.
Sure. So we're one of the companies in Erik's map of UAVs. I see that you've given a shout out to Mark Schuck. Also good to see him. That's sort of where we started our journey, working with H3 Dynamics fuel cells. Now we're working with someone else, but we're working on hydrogen powered drones. We're looking at the commercial space mostly. And we are trying to make one of those drones actually be commercially viable, because as I'm sure Erik knows, there's lots of companies who advertise those drones, but very few that actually have them flying, and even less that make economic sense for the commercial world. There's some very exciting companies working on military stuff. We're not there yet, but we're very excited about Erik's technology. Erik, it's good to see you.
See you.
I just wanted to nail you with the question that I ask over and over to you again and again about the capital expenditure required to make this technology work. You obviously mentioned today the expectation of cost for the aluminum, but there's obviously all the capex required for the equipment, and obviously the logistics to moving the source of production to the site wherever you're going to use the hydrogen. Obviously, in the military, it's very different than in the commercial world, but do you guys have an expectation already of upfront cost for the different pieces of equipment that you showed, for example, for the drone refueling items? And then how easy is this to transport, say, in a trailer or in something similar that you require to have this infrastructure moving around with the drone?
Yeah, so let me address that last question first in terms of mobility. We're designing our systems to be one or two person lift. And we already demonstrated this back in 2022 with the Marine Corps at Camp Lejeune, the HTOP project, where we had our system in probably 3 or 4 Pelican cases, each one of which could be offloaded by 1 or 2 Marines off the back of a truck and then assembled in 15 minutes to operate. The moonshine hydrogen reactor, the kegs, those only weigh 20 pounds each. And then the cases weigh maybe 50 or 60 pounds. So the system is designed to be highly mobile. And that's what we mean by expeditionary infrastructure. Right? This is quote unquote infrastructure that's intended to be very mobile and lightweight. some people have expressed a desire to not have to do the interconnections in terms of hoses and wires, and so we've also looked at putting it on a trailer, because the entire system all together is less than 200 pounds. So something that we can very easily put on a trailer, such that it's kind of plug and play, ready to go once it rolls onto the site. In terms of cost, we are right now working through those numbers. There are a couple different options, especially for the high pressure reactor. You can either get a very inexpensive steel pressure vessel that doesn't cost very much as a reactor, or you can put it weighs a bit more, or you can use a COPV as a reactor, which is much lighter weight, but perhaps a little more expensive. So I think the price point is going to be kind of two different levels. For the lighter weight, even more mobile systems, we're pricing it to be less than the cost, probably half the cost of a Group 2 drone, such that a industrial or military end user can get a UAS, a full system. So that would be 2 drones plus our reactor, at only a 25% increase in the total system cost. And then for the, let's say, perhaps lower cost systems like the one that you're developing, probably be about the same as the cost of your drone, such that it could be scalable.
Okay. Because the logistics that I'm thinking through is, if we're gonna put it on a trailer, I mean, that for our use case, commercial customers who are using a hydrogen drone, say for inspection of power lines or pipelines or something in the States, you'll have a trailer that's pulling the drone. It's pulling compressed hydrogen cylinders that go on the drone, and then you'll either have a compressor, and you'll have fuel cells, or you would replace those fuel cells and the vat of water with your system.
And the compressor, you can replace the compressor as well.
Yeah, that's right.
Yeah.
Well,
so
I'm actually, that's another question I have. I'm not entirely sure how much you replace the compressor, unless I know you want to go eventually above 5,000 psi, right?
So I presume that your tanks are, like most UAV tanks, are at 5,000 psi, right?
350 bar.
Yeah, 350 bar, right? So the way that we operate is you connect one of those cylinders to our reactor. It starts doing the reaction, and it dispenses the hydrogen directly into the tank until it reaches 350 bar, and then it turns itself off. And so you'd be refilling the tanks on site at the desired pressure level without the need of having any compressor. And part of the reason we're doing that is we've been told that the compressors are by far one of the lowest reliability components in that entire supply chain. Are significant power draw and significant weight. And so if we can eliminate that complexity, that's the ultimate goal. Because it seems kind of silly for us to eliminate the need for hydrogen logistics, eliminate the need for let's say 1,800 or 1,200 psi cylinders, but then have to run a compressor run off of diesel in order to get the hydrogen to breaker. So we're specifically designed to fill the cylinders with self-pressurized hydrogen from our robotic circular reactor.
Yeah, I agree that's the appropriate path. And then I'm guessing we could connect, for example, our drone currently uses a 12-liter cylinder, but we're upgrading to a 15-liter that you'll get to try. You know about that one, but with those, we'd need about 3 per day to fly for the entire day. I'm guessing that there's a way to connect maybe 3 of those on a pipe or on tubing, and then leave those 3 charging for the entire day. Or how quick is the reaction?
So we can throttle it. I said we've done as much as a kilogram of hydrogen in 5 minutes, but that was at ambient pressure. I think are likely do one tank, one cylinder at a time, and obviously you can connect all the cylinders, and the system would just switch from one to the next to the next, just in order to get that pressure up to target within a certain time frame. Our goal is to do one cylinder refueling every 1 to 4 hours, depending on the size of the cylinder.
Okay. Awesome. Thank you for all the answers, and we'll chat soon later.
Sorry, Roberto, I missed what is your company?
Selling right there.
Oh, you're selling. Okay. We have met then, maybe.
Via email, yeah.
Okay.
We're missing a call, which I'll email you for it as well.
Okay, yeah, we'd love to have you on here.
Thank you
I think
both.
yeah, thank you. Thanks for all the questions. Thank you so much, Erik, for your presentation. Thanks to Edge. I'm so glad that I've learned a lot. I have a lot more questions. I'm not gonna ask them all here, but I want to just quickly share my screen and show you all where you can find the recordings as well as lots of other goodies. So if you go here, so connect.hysky.org. Let me just put this link in the chat. Then if you click explore or join, it's free. Then you'll see events, and I gotta go. Once you're logged in, so once you create your account, you will see events, and you will see HYSKY Monthly, and you'll see past webinars. And so this is where you can find the recordings and the slides. So there's loads of stuff in here. You can also access flying high stuff, which, loads of people with loads of presentations, recordings and slides. So definitely go there, create a free account. That's pretty much especially, if you're looking for partners or customers or just collaborations in general, that's where you're going to want to go. So with that concludes our first webinar of 2026. Thank you so much to Edge, you, Erik, and Alex. Please tell him thanks for helping get this organized, and we'll talk soon.
And Danielle, I've done a lot of writing on this. I put some links in the chat to some of those articles in the military press, as well as a bunch of videos online. Look forward to
awesome
checking those out. Take care. Thanks for that.
Danielle,
yes,
I put the equations in your chat.
Oh, nice. I see them.
I put
Very
mine.
cool.
I'm assuming what Erik is using. So be careful. You got to check everything. Okay. Erik,
okay, very
delightful
good.
listening to you.
Thank you. Take care.
It was. Yeah, so we'll do a write-up on this webinar, and so we'll include all of those links and the equation, and then Erik will give you a chance to say, no, that's not what we're using, or that is. But again, thank you so much, everybody. Enjoy the rest of your week, and we'll see you next time. Bye.